Prior to this lesson, we've been working on some algebra skills and our factoring skills, and now we're starting into our actual polynomial functions. So our goal today is to be able to identify a polynomial function by its equation. So look at an equation and decide, is it a polynomial or not a polynomial? And from that, we can identify key characteristics, including the degree of the polynomial, the leading coefficient's value and sign. And with the help of technology, we can state the end behaviors of the graph and the domain and the range. So just as a quick recap here, a function we know is that for every value of x in the function, there is only one matching y value. When it's graphed, a vertical line will cross the function only once for any given value of x. So we talked about this earlier. So that vertical line is called the vertical line test. If it doesn't have just one y value for any given x value, then it isn't called a function, it's just a relationship. Now, we're going to talk here about some polynomial functions. And polynomial functions have this overall format. Now, this looks really, really big and long, but what this is saying is we've got a number, an is just a number, times x to the exponent n. So this little n here is just a subscript saying that a is the coefficient of the x to the exponent n, and then if I had an x with an exponent 1 less than the one before, the coefficient that goes with it is a with a subscript n minus 1, and so on, all down to a with a subscript of 1, x to the exponent of 1, and then this represents our constant term. Okay, so that's a standard form version of any polynomial function with any degree. When we look at polynomial functions, these exponents on your x can only be whole numbers. You can't have a fraction as an exponent, so you can't have an x to the 1/2. That's not going to work. That's not polynomial by definition anymore. It becomes a radical function. Likewise, you can't have any square roots or cube roots because, like, x to the 1/2, that's the same thing as the square root of x. So that doesn't work. You also can't have negative exponents on your variables. So if you had x to the -1, that's actually equal to 1 over x, and that's a different kind of function. That's called a rational function because it's a function that's a fraction with the x on the bottom. So following that, then, no variables can be in the denominator of the fraction because that then is a rational function and no longer a polynomial function. The dependent variable, your y value, must have only an exponent of 1. You can't have a y squared or a y cubed or a y to the 1/2 or y to any other exponent. It has to be a y to the 1. You can't have an exponent that's a variable. So for example, we already looked at y equals 2 to the x. That is an exponential function. It's a different kind of function. And when we graph these, the ends of the graphs, the end behaviors of your graph must go to positive infinity or negative infinity. And we'll explain that further as we get going with our graphing. All right, if you look in your duotang, there are some examples and non-examples of polynomial functions on page 3.1. So you can take a look at that and see how they compare to our instructions here. Okay, a degree of a polynomial. So we actually have talked about the degree of equations before, and really that's what we're looking for. We examined the exponents that are on the x, and the highest exponent on any term with an x in it, that is your degree of your polynomial. Okay, so if I look at this example here, state the degree of each polynomial function. So all of our exponents on our x are whole numbers. This we know as a quadratic function. It has a degree 2 because the highest exponent on the x, this is an x squared, this is an x to the 1. This could technically be an x to the 0 because anything to the exponent 0 is just 1. So that's 25 times 1. This is degree 2. Okay, a second degree, it's a quadratic function. So we know when we graph it, it should give us a U-shaped curve. It's the parabola. So our parabola that opens up or opens down. Okay, so that's a degree of 2. All right, take a look at the next one here. The highest exponent on the x is a 3, so that makes this a degree of 3. And we're going to look at these higher order polynomial functions to find out what happens with those. Take a look at C. This one doesn't have an x at all. This has just an x, which means it's x to the 1. That's a degree 1. That's going to be a linear relationship. Okay, and in fact, the slope is -4, so we know that that line should go up and to the left or down to the right. So that's a linear relationship. So lines are polynomials of degree 1. Parabolas are polynomial functions of degree 2. This is not in standard form. We could be nice, write that out twice, or square the first, double the product, and square the last, and simplify that. So that's going to give us negative x squared. That'll be a plus 4x when we expand the negative through the bracket. A minus 1 times the positive 2 would be minus 2. Minus 2 plus 3 would be a plus 1. So that also is degree 2 here when we put that in its standard form. Now we should already know that that's degree 2 because that actually is the vertex form of our parabola. All right, I'm just going to write in a definition for degree here before we talk about the leading coefficient. Okay, so the degree of the polynomial is the highest exponent on x when the polynomial is written in its standard form. That is your degree. So that's why with D we actually expanded and simplified to prove that that actually is a degree 2. All right, leading coefficient. When we write our polynomial in its standard form, let me just zoom in here. When we write it in its standard form, the leading coefficient is the coefficient or the number in front of, oops, let me grab that, okay, our number in front of that highest power of x. Okay, the number in front of the highest power of x. So if I look at my example 2 here, my highest power of x is x squared. The 4 is our leading coefficient. Okay, and that's why we stress the leading coefficient will tell us some things about our polynomial function, and that's why we talk about putting it, when we write our equations, putting them in descending powers of x. Our leading coefficient here would be the positive 6. This one's not in descending powers of x, so I'm going to rewrite that in this manner. And that makes the highest power of x is x to the 1. Our leading coefficient is -4 here. And you should recognize that -4 as being important for that line. That tells us our slope of our line. Similarly for part A, if I jump back here for a moment, that was a positive 4. That's telling us we know our parabola is opening up. Okay, and we talked already about that slope of -4. That line's going to go up to the left or down to the right. This one, when we expanded that, we ended up with a negative x squared and a bunch of stuff after that. So the highest power is x squared. The leading coefficient here is -1. That told us for a parabola that that parabola was going to open down. So this is going to come into play further with our polynomial functions. So this leading coefficient is important. All right, so I will type in a definition for that, and then we're going to talk about this graph here in a moment. Okay, so the coefficient, or the number in front of the highest power of x, is the leading coefficient. And again, that's a reason why we write things in descending powers of x. So that first coefficient is our leading coefficient. It's the one that leads the pack. All right, we're going to talk about end behaviors, but before we talk about end behaviors, I want to define a couple of things on our graph that I have here. We know that our Cartesian plane is broken into 4 sort of sections called quadrants. Quad means 4, so 4 sections here. We have a little section in the positive, and that's called quadrant 1. Quadrant 1, and we sometimes use Roman numerals for that. I'm just going to use my regular numbers for that. Let me just write that up here. Okay, so that's quadrant 1, and then it goes in a counterclockwise direction. So when your x is negative but your y is still positive, that is quadrant 2, and it continues around in a circular fashion here. Quadrant 3 is in our bottom left corner. Come on, text box. There we go. Quadrant 3 goes here, and then quadrant 4 would be down here. Add, come on, there we go, quadrant 4. Okay, so those are our 4 quadrants. If we're ever talking about them, you need to know which one we are referring to. But you should be familiar with that from previous classes. All right, when we're talking about this thing called end behavior, we're really looking at what happens to the y values as x gets larger and larger. So if I follow along my graph here, if I was looking as x gets larger and larger, so we head this way on the x-axis, do you see that the y values are heading up and up and up? So our end behavior for this one is as x approaches, so that arrow means approaches, positive infinity, so that's the infinity symbol, our y, or our f at x, is approaching, in this case, positive infinity as well. We also want to look at the other end. As x heads this direction and approaches negative infinity, you'll notice that the y value is heading towards negative infinity as well. So we would say as x approaches negative infinity, y approaches negative infinity for this graph. So this is all kind of new language here that you're going to need to get used to writing. These are called the end behaviors of our graph. That's our end behavior. It's really looking at what's happening to the y as x gets infinitely small or infinitely large as it approaches negative infinity or positive infinity. Or we could say the end behavior goes from quadrant 3. So our graph, if we read it from left to right, our graph comes from quadrant 3 and heads towards quadrant 1. So you sometimes will see it written the way I wrote it in red. You sometimes will see it written as Q3 to Q1. Both are acceptable. If you take advanced functions, MHF4U, I believe the textbook that you'll be using for that course uses the Q3 to Q1 method. The handouts that I'm going to give you will use the method in red. So you should be getting used to both methods. So if you go off to college and need to know these things, you'll be familiar with it. Okay, I'm just going to put a little blurb in here about what end behavior is, and then we'll move forward. So hopefully that is clear, that makes sense, and the 2 ways that you can express it you should be familiar with. If you're not sure about any of this, please make sure you're asking for help. Okay.